Okay, we're going to go through the different methods for multiplication, which again, they're all kind of related. Let's do the standard algorithm, 57 times 84. All right, and this is where you do like 4 times 7 is 28, and you put an 8, and then you bring the little 2 up. And then 5 and 4 is what? 20 plus 2 is 22. And I'm going to cross it off. I'm going to put a 0 down here. And then I have 8 times 7. I view that as 56, so I put a 6 with a 5 up here. I view 8 times 5 as 40, plus 5 is 45. And then I add down. So 8, 8, 7, and 4. So 4,788. Again, not a lot of understanding. I'm just viewing those as 4 times 7, 4 times 5, 8 times 7, 8 times 5. I mean, I'm not really viewing any place value. Okay, that's the standard algorithm. Now, partial products. Again, anytime we say partial sum, partial differences, partial anything, we're focusing on place value. So I have 57 and 84, and I'm going to draw a line underneath that, and then I'm going to draw like an L, so like a vertical line going down to the right. And off to that, I'm going to view this as a 4 in the ones position, but I'm going to view it as 4 times 7. So off to the right, I'm going to write 4 times 7. And then I'm going to view it as 4 times 50. Not really 4 times 5, but 4 times 50. So it focuses on place value. Then I'm going to go look at that 8. And that 8 is not really an 8, it's an 80. So I'm going to view it as 80 times 7. And then I'm going to view it as 80 times 50. So it all focuses on place value. So I wrote all of those multiplication facts off to the right. And then I'm going to do them. So 4 times 7 is 28. And I'm going to line these up vertically. 4 times 50 is 200. I'm going to line up my place values underneath the 28. 80 times 7 is a 56 with a 0, 560. 8 times 5 is a 40 with 2 zeros, 4,000. And I lined up my place values, and then now I'm going to add. So I get 8 in the ones position, get 8 in the tens position, I get 7 in the hundreds position, and 4. So 4,788, which is good. It's the same answer I got before, so that's, kind of promising. All right, FOIL is really kind of the same thing as this. So they're all interconnected. FOIL is what you did in algebra. Remember when you did like x plus 2 and x plus 6, you would have done first x times x is x squared, outside is 6x, inside is 2x, and last is 12. And then you would have combined like terms in the middle, okay? That's FOIL. So we're going to break these into 2-digit, and we're going to do the same. So if I have 50 plus 7 and 80 plus 4, first is going to be my 50 times 80, and I'm just going to write that down, plus outside is going to be my 4 times my 50. My inside is going to be 7 times 80, and my last is going to be my 7 times 4. And again, notice same we get here, right? It's all interconnected. So I get 4,000 plus 4 times 50 is 200. Plus 7 times 80 is 560, plus 7 times 4 is 28. And then I might take my 4,000, I might combine my 200 and my 560 into, what is that, 760, line that up, and then my 28, and then add that. So kids might kind of do a little bit of combining before they line each up. And again, 4,788. All right, the other one is the box method, which is, again, all interconnected. FOIL is the same as the distributive property, okay, because you're distributing the everything to everything. Okay, same thing here. We're distributing everything to everything. Same thing here. So again, the box, all of these are based on the distributive property. So I'm going to break in my 80. I'm going to put 80 plus 4 on top, doesn't matter, and my 50 plus 7 on bottom. So I'm breaking it into place values, again, kind of like partial products, kind of like FOIL, but I'm drawing a rectangle and cutting it into 4 pieces. So then it's kind of, this is more of an area model. So 80 times 50 is 4,000. I'm going to put that in the left upper corner of my box. Then I have 4 times 50 in the upper right, so that's going to be 200. Then in the lower part of my box, I have 7 times 80, which is 560, and I'm going to put that in my box, and 4 times 7 is 28, and I'm going to put that in my box. So again, kids are probably going to add some of these together. So like they might even add like the 4,028 to get that added, and then they might get their 760 added up. So they might add the 4,028 and the 200 with the 560 just to save themselves some adding, okay? Or they might line all 4 of them up to you, but they're still going to get 4,788 when they add up the 4 pieces in the box. So these are most of our conceptual one. The other one is using grid paper, so we'll probably talk about that tomorrow. Lattice is kind of the new standard algorithm. So with Lattice, if I have 57 times 84, we're going to make a 2 by 2 grid. So a box with a plus in the middle to make 2 by 2. And we're going to draw diagonals from corner point to corner point going upper right to lower left. So if you have the 4 boxes, the one in the far right bottom, I'm going to go up from that corner and draw a dashed line down through the corner. Okay, in the middle, I'm going to go up a box to the very far right corner of my grid, and I'm going to go down through the middle and down through the very far left corner of my grid. So going from the top right, drawing a diagonal through the middle, all the way through that bottom left corner at a diagonal. And then my very top left box, I'm going to put a dot at the right corner of that and draw a dashed line cutting through that guy too. So every box has a dashed line cutting diagonally from the right corner to the left corner, and that extends out of the big shape. So out of the big square, those extend. Okay, it doesn't matter. I'm going to put 57 on the top. So 5, 7, you don't put place values. So you just put 5 and 7, and you put 8 and 4. This does not focus on place value. This is just a trick, okay, just like the standard algorithm. Okay, 7 times 8 is 56. So I'm going to put a 5 and a 6. In the top right corner, the 5 is above the dashed line, the 6 is below the dashed line. Okay, I'm going to do the bottom right corner. 7 times 4 is 28. I'm going to put 2 above the dashed line, 8 below. Far left quadrant, I have 5 times 8, which is 40, so I'm going to put 4, 0. 4 above the dashed line, 0 below. And then 5 times 4 is 20, so I'm going to put a 2 above the dashed line and a 0 below. Okay, then what you do is add down your diagonals going down towards the left. So the 8 is just 8, so I'm going to put that there. 6 times 2 is 8. 5 plus 0 plus 2 is 7, and then the 4 is there. So I get 4,788, okay? Those are the main ones. Let's see, I'm trying to think. We did standard, distributive, FOIL, partial products, and lattice. And let's see, the box method, yeah. The only other one I could think of is if you only want to distribute part of it, you could do that too. So if you have like 57 times 84, if you wanted to, you could break it into 50 plus 7 and then 84 and not split it into like 4 pieces. So just 50 plus 7 and 84. And then what you could do is just do like 84 times 50 plus 84 times 7 if that's easier, okay? So then here I take 84 times 5, and we'll talk about some mental math strategies later. So 84 times 5 would be 0, what is that, 42? So 420, 84 times 7, what is that, 56, 57, 58. All right, and then let's see. I need to tack on, what, an extra 0 here because this is really a 50, so I need to tack on an extra 0. So then 420 plus 588 is 4788. So 4,788. So I could just break one of them apart and do the distributive property. Usually we only do that if it's easier. And in this case, I don't know that it made it a lot easier. Sometimes it does, like when you're dealing with quarters and things like that. And we'll talk more about that later. All right. Hopefully that helps. Again, we will keep working on these and we will keep getting better. All right, take care.